Ladies and gentlemen, please welcome our next speaker, Laurent Balmelli, presenting the topic, Rediscovering DevOps Heartbeat, a journey with cloud development environments.
Something tells me that was AI generated, right? Yeah. Okay. All right. So let me. Currently, I was speaking here last year. Apparently, we have people introducing us, but like this year, we have introduced ourselves. So I'm gonna tell you a bit what I've been through. So thanks a lot for attending. I was not expecting to have a lot of people, but that's a good surprise, especially with the guy before the full room. So I was thinking, like, then they get bored and they're gonna go for a drink. So thanks a lot. I'm gonna talk to some about some work basically I've been doing recently. I also have a publication. I come from academia. Let's put it this way. I have a background in research and I did a PhD, so I'm used to when I write when I actually give a presentation, I like to write an article that goes with it, and so I'll refer to that one as well. I'm from Switzerland. Obviously that looks like a Swiss flag, but also like the Red Cross perhaps. But like I grew up there, but I lived over half my life outside Switzerland. I lived in New York. I lived in Tokyo, about 15 years in total. I worked for IBM Research, so that's a research division. So I have a background in innovation. I'm interested basically in trying some new ideas, and don't get me wrong, often they're stupid, but like that's how you need a lot of failures to try something good. So I think that's part of the process. But in general, I think it's good basically to try new things. This is what I want to talk to you today. Also, I like to create companies, especially creating product. Getting the companies is not too much my stuff. So I had also background in cybersecurity. I did a lot of thing about like cybersecurity. Also like on independently testing things, breaking things. But also I had a company, Strong Codes, that was doing code obfuscation. I don't know if that rings a bell for you guys, but like it's something that relates to preventing reverse engineering of applications. Work on that in 2013. We got acquired by Snapchat. So then I worked for Snapchat in 2016 from 2020 as the head of cybersecurity based in Switzerland. And then I decided, yeah, fuck it, let me do another company. So now I do Strong Network, and there I am today. I'm working on this. I'm more on the innovation side. I have a background in CS, computer science. My PhD went more into the mathematical side of information theory, but I'm really into like coding. I really like that, and that's what I'm doing in my company. But mostly on the product side, I have my partner is the CTO, who was my ex-employee at Snapchat. When I left Snapchat, he followed me and we created that company together. Is the part of engineering. I'm doing the product. I mentioned this. I really like to write. So if we go on a website, Strong Network, this is where I'm publishing very often new articles that are published around also not only on the website, but some article I publish on the News Stack and some other like D-Zone and Developer Zone. That they publish my article pretty much all the time because it's a submission process and so on. And so you can take a look at this. But I'm going to talk about one of the things that I've been doing recently. It's rethinking of DevOps. So we have T-shirts also. If you like T-shirts, like the one I have, for instance, here. Or you like skulls? I like skulls. So I mean, come see me. My marketing guy will send you a T-shirt. Just give me the size, and be happy to do that. So the why, what we do, and the idea is that if you want to rethink DevOps, and I'll mention what I mean by rethinking DevOps, is that you need to understand, what's the basis, right? And who read that book? A few people. Good thing. All right. So I think it's very important, right? It's not too much antiquated. I think it's actually quite in touch with what's going on with DevOps today. It was written about 10 years ago or so, or perhaps a bit less, 2015. Yeah, well, also, almost 10 years ago. And I think it also explains that DevOps is not only for computer and thing, it can also be applied to other disciplines, which is actually something that is difficult to grasp if you have the experience for the whole thing. But it's actually very interesting things that the guy Jin Kim and Jez Humble, they talk about the 3 ways. So this is something that I think is it's really fundamental for DevOps, and we kind of live these 3 ways every time we work on code development, and think DevOps is not. I know it's very often related to people working on deployment, so on the cloud, but DevOps is actually started from development, right? It is already have dev, right? It's not only operations, and it's not only about scripting, right? So there's kind of a bastardization of the term, thinking, oh, I need the DevOps guy. I mean, okay, this guy is going to do deployment. No, not necessarily. It could be a coder. It has to be in tune with the methodology, and has to understand, how things are applying, and so this is an important thing. But like, you can see the 3 ways are depicted here, I think, in a very easy way that you can actually understand what it means. The principle of flow. So the principle of flow is the first one here. That means like you have to go smoothly from dev to operations, right? So make sure that you have, shift from the configuration that when you work on your laptop, things going to go in testing, when they go in production and stuff. They has to have the same environment, right? It's not the same libraries and dependencies, or like the same data, right? So because otherwise you can run something on your laptop and it's not going to work in production. So you all know that, right? I don't have to tell you that. That's the first thing. The second way, or DevOps here, is the principle of feedback. So you actually want to make sure that when things go to development for operation, you have a way to get feedback. But it's actually something that happens all across the process, not only a big loop across the entire cycle. Like, very easy way to picture the principle of feedback is also the pull request. Make some code, and somebody's gonna give me some comments on this, and I'm gonna correct the code and so on. So this is also part of the principle of feedback. And at the time the book was written, I think he mentions the pull request. He mentions also more abstract things, but I think one of the very easy and daily characterization of the principle of feedback is the pull request. And then the third one here is a bit more philosophical, but I think it's very important, is the principle of continuous learning. And this is something that's part of the methodology, part of the culture. And I think this is something that companies start really to embed in their processes, is that they will make sure that they continue optimizing the pipelines, optimizing the process. Actually, now this abstraction of platform engineering and things that come on top of it, if there is such a thing, then this is part of the optimization, continuous learning, and so on. We want to optimize that process. So what I was thinking is that when I started working on thing I'm working on now, which is going to be the next step, I was thinking, well, perhaps we can actually give a new spin to these 3 ways, and perhaps come up with something new. So episode 1 is the online dev. So what is the technology that we're bringing on the market that actually can make you rethink the 3 ways of DevOps? So that's the cloud, but applied to coding, right? So there's a trend for the recent years, actually it's quite more, but it's really became popular the recent years, of putting development environments in the cloud. And a lot of companies are coming up with products, and the goal is really to migrate from having a local environment where you're going to code, to something that will be remote, and you will be connected to it, whether you know it or not, because it could be actually some really in the background connection. But actually it will bring you a bunch of advantages. But this is one. So the easiest way to realize that transfer is to say, well, I'm using Docker, I'm using whatever you use for containers. Docker is obviously a very prevalent one. That you're gonna do your Docker build, Docker pull, Docker run, and all things from your laptop here. an alternative to this is to say, well, actually, you could deploy my container in the cloud and run it as like I would run a virtual machine, right? And this is in principle is the same because you're going to be able to connect by SSH or HTTP, and anyway through a port, and then you're going to be able to access to it. And the goal here is to have all the code that you author on your computer in the cloud as opposed to be on your laptop. So that's basically in principle this is it. And just for the abstraction is that it looks like a virtual machine. You all SSH in your life to your machine at a remote host, right? You SSH the name of the host and you get connected and so on, as long as you can authenticate. But it's actually on the endpoint. It's not like a virtual machine. It's a virtual process. So if you want to run this, you might have to run this on Kubernetes or something, but it's not going to run by itself. But basically, you're running a virtual process, and there's multiple advantages to this as opposed to a virtual machine. Would be obviously the speed, right? It's going to be much easier. It's like when you run your Docker. A Docker run takes like a few seconds, right? If you run your virtual machine, it's going to take a bit more. So a lot of people are doing this. I mean, one of the well-known one, because they have a huge marketing budget, is GitHub Codespaces. Who has used Codespaces? Only one person? Oh wow. Okay. So there's a startup called Gitpod. There's Google Workstations. There's us, and so we're not the only one doing this. It's like a lot of people are doing that. And as usual, there's multiple ways to do it. One thing is that, and I'm not going to go into details today, we're not talking about technology, is that we're just doing very, very differently, just because I'm stubborn and we like to do things in a different way. But and I'll clarify that because that's part of the rethinking of the DevOps principle. But this is the industry is moving. That trend is moving. So perhaps in new company, if somebody brings the idea, oh, we could put an environment online, and that, don't be surprised, this is what's happening, and there's many actually companies moving there. It depends on the industry. Technology, like technology companies, the development companies, they do it, but this actually quite prevalent in like industries like banking or insurances and so on, because they have needs that perhaps are a bit different. Just if you want to know why and how we made cloud development environment secure, this is an article that you can find on our website, and also I think I published this in different venues, but this is thing. So if you've never seen that, since only one person has used Codespaces so far, I'm just going to show you how it looks like, because it's always good basically to see it once to kind of wrap your mind around that and around it and think this is, I understand not how it works. So let me just show you how it looks like. So you can go on your this is your dashboard. When you log into the thing, you get like a bunch of things. Those are machines. Think of it like these running machines in the cloud, and I can see all of them because actually I'm the security officer. This is bunch of people working. See, Marco is typing here. I can see like Alexa is working here. Bastian has a new workspace and so on. And Bjorn, and even Bjorn shared it with me. See, I can actually go and open it. But what's going to happen is that those are the machines, and you don't actually need to SSH to this machine. You can simply open this machine here with Visual Studio Code. And then this is connected, and then you connect and you can start working. So you can start coding, right? So the goal is and this is a Chromebook, so nothing's installed. And this is a machine, right? This is a Unix machine. So Linux here, and I can start working, and I can, I'm sudo, so I can actually do update and so on. This is like a normal machine. In the background is actually a container running on Kubernetes, but it's definitely like a machine. What I don't do much, because actually I'm actually updating the website with my articles. So I did a bunch of script to automate this, because you want to automate stuff. So that's the only thing I do. But that, to me, it's very useful, because I can just go by. And usually what people have, they have multiple of this machine, like one per project, and it's completely isolated dependencies from other things and so on. But this is the thing. So if you've never seen that before, this is how a platform look like. I'm not sure exactly how. Codespace might look a bit different, but in a sense, it's exactly the same thing right here. And there we go. Let's go back to the charts. So you have seen this once. There you go. And now we can see, like, So one of the great stuff about this is that it's actually really easy to onboard. When you want to onboard somebody on a project, well, everything is there. Usually a platform like the one I showed you here as a way to manage containers, continuous definition, or you can create a workspace. This is what you saw, like this little thing running. The avatar for this little tile is a workspace. This will be running Kubernetes, and it starts in a few seconds, and then you can onboard somebody with a fully installed environment and so on. I'll get back to you also the kind of the abstraction of this workspace, but like you can onboard people. So onboarding developers is really fast. That's really cool because we all developers, it takes time. Actually, I gave up on my Kali machine because always like updating dependencies and stuff. Like it was kind of you have multiple projects, and I had to segment things. So I think to me it's easier to work with it this way. So onboarding is easy. So if we go back to the principle of DevOps, the 3 ways. The first way was the principle of flow. So one of the things I'm going to say, like, now that we have this environment online, the next thing I want to think now, okay, how does that change these 3 ways? Is that way that we can you can re-express these 3 ways in a different manner? So the new flows. One thing that I was just reminding everybody was the principle of flow, and it's just like typically out of the book, right, out of the DevOps handbook, smooth and efficient movement of work from development through testing, deployment, down to operation and monitoring and so on. You want to minimize bottlenecks, optimize process, and so on. So this here, when that was written, is really thinking of people working, on I would say on an equal basis, or not necessarily people having some different roles in the company, but like they are developers and then trying to optimize the thing. One thing that is great when you have development environment online as opposed to on your laptop is that you can do really new things with that. So think now, you have a team. This team is distributed. They have people all over the place, and everybody has her environment online. So what's going to happen is that now you can actually define, well, you need an RBAC model, role-based access control model, but actually you can have a very diverse team of developers and control the flow. And this is one of the really interesting thing is that now the development is online, it's actually very easy basically to get control on the flows, and you're not dependent on only seeing what's happening once it's pushed on GitHub or GitLab or things like that, right? You can actually start seeing before it happens. So because you have the environment online, I'll show you some of the metrics that we have, is that you can get a view of what's happening as it goes when people work on the code. And it's going to give you interesting metrics that you see. For instance, you can know how long it takes on average for my team to compile their code, to build their code, right? Which is information you will never get once the development happens directly on the laptop. So people still use laptop, but in the background they connect to this online environment, and now you get visibility. So the principle of flow is completely different. And I think this is really the onset for all the the next changes that's going to happen for the principle of feedback and so on. But you have to recognize that, and this is why actually cloud development environment became a Gartner category. Gartner, the analyst, last year they came up with that term, cloud development environments, and this is something that people are enjoying because it gives like a way to centralize development environment. So that's really the really fundamental thing. You centralize the environment and you can get a better visibility. So principle of flow is improved. So now the feedback, and I think this is where we start to get very interesting because we can get different. Now that we have all these environments online as opposed to being on the laptop, then we can get very different feedback. So the principle of feedback, that's just something that you want to give to your developers or your managers or your people who are working for you. And I'm just reminding what it is. So establishing a mechanism for communication, collaboration between different stages of development and operation processes. It enables better collaboration between developers. So I mentioned the pull request has been really obviously a notorious feedback process, feedback mechanism. And this is something that it's known, but like we can go much further. And one of the things here is that thing I was mentioning before. Now that you have the environment that is online, you can know a lot more things. So what's going to happen here is that first of all, you can know how many your team consume in terms of CPUs and memory, because whenever you create an environment, you can actually, you get this kind of avatar as a way to represent the environment, and then you can have consumption. So what's going to happen also, but this is perhaps the first thing that you need to realize, is that every time I work on my environment, so I'm connected to my, there you go. I'm connected to my, thing. When I compile anything here, it's not going to happen on my laptop, right? I mean, everybody, made an SSH connection to a remote host. Understand that when you make build, that is not going to happen on your machine, right? It's happening remotely. So one of the things here is that you have a total view on consumption of the project. You have a total view on the time it will take to build, and you can actually optimize this type of metrics, right? Which I think is could be a different ballpark. It's not possible if you don't have an environment online. So I think, and let me go back to my stuff here. Yeah. So you don't have. So the first I think interesting aspect here is that you can know typical consumption and so on. And also one of the great things is that, well, one of the issues that we have now with development, especially if you do cloud native development, is that you often do not have a machine that is powerful enough. Even if I have the MacBook Pro, which I don't have MacBook Pro, I have actually Chromebook, which to me is perfect because I can connect to my cloud, and ours we deploy in AWS here. We can connect to the cloud, and actually, if I need a 2 CPU, 4 CPU, 128 CPU, I can actually add this machine by the hour. And when actually you specify, you build a workspace, what you're going to do? You're going to do exactly that. You say, well, what kind of thing I need? So I go here, and I'm going to build a workspace. It's like I would actually choose what kind of thing I need here. All right. Those are things that are pre-made by the admin. We can have but you can get any type of machine, and you can change when you create your workspace. I can actually edit my workspace and say, well, now I need, for a few hours, I'm going to map my workspace on a very, a powerful CPU. So this is completely now, detached from the performance that you have on your laptop. It's you have this on demand and also being build on build exactly build on usage, right? Which is great stuff, right? So when you have this, then also, because when people compile with their environment, you can actually retrieve information from it. So we can see actually, well, the build performance here is 3 minutes and 1 second, because this is what it took the person to, if you time the command make build, this is what time it took, right? So what's going to happen here is that you can actually look at if your team has enough performance. Do you need to assign more CPUs to your team and so on? And this is typically what we have. So this is from 1 year. Our build is taking on average 2 minutes and 13 seconds, and we compile about 12,000 times in about the last year with the team. We're not a big team. We're about 20 people, so I think it's okay. But this is what it takes, right? So I can say, well, perhaps if I have the build in 2 minutes, I can compile more. I can do more experiments and so on. But all things. This is typically things that are new with that. But you can get more feedback. That's when it becomes interesting. So there's a few things here about security, because obviously my background is cybersecurity, so I was also really interested. This is why we created that thing. Also, I know what makes us different from anything that happens that exists here is that we have this view on security that is completely, I would say, specific and unique to what we do. So just to go very quickly, because otherwise you wouldn't see the relevance of this discussion here. So this is cloud development. Typically, I'll mention the code spaces, the thing like that, and this is us. So typically, these guys here will give you an IDE that will connect to a container and so on, which is fine. This is completely fine. If you productivity is your gain, well, this is completely fine, right? I mean, that's fine. What we decided to do is basically also to give that same access to here, but we want to have control on the infrastructure security. We want actually to make sure that when you connect to your container, when your container connects to resources, here could be Git resources, SSH host, it actually goes to a proxy, because we want to control all this. And one of the things we want to control, we want to actually free developers from caring about any authentication. So if you need basically to, in your environment, you need to SSH to a host, We don't want you to have to manage your keys yourself. We don't want you to do SSH keygen and then have the private key on your environment, the public key on the remote host and stuff. We don't want that. Forget about that. I think it would be much simpler if you just SSH and don't care about the authentication. Same thing with your project here. When you do the git clone, well, you don't have to make sure there's a key or token. You don't have to make sure about these things, right? So because there's two advantages. First of all, it's much easier for developers because you don't care about these type of things, and also it makes them immune against phishing and malware, which is very, if you read the news, I mean, like, so these are like, I think Okta, Slack, and Circle CI, they all got hacked with this type of thing, phishing of the. I actually wrote an article on that. They go hacked with phishing attacks and so on. So that's the thing. So one of the things here is that we want actually to prevent exfiltration of credentials. That's why we make sure that this is protected, and this is one of the things that happen is that in order to really enable this, we actually need to see this as the infrastructure that you need to protect. So when you want to control security. This is why these guys, they don't do security, because to do security, you actually need to control the entire stuff. So it's a pain, because it's going to be a lot of things to implement, and especially one of the things is this. So we cannot only rely access with an IDE. We actually need to have an enterprise browser. So who knows what an enterprise browser is? The very popular things right now, there's like Island, Talon, Citrix has one as well. Like basically the whole industry also is going to enterprise browser, because apparently your Chrome and your I think obviously is not designed for security, and actually Chrome has Chrome Enterprise as a version which has like DLP and all those things. So all large companies, they're moving to an enterprise browser because they need to control basically lots of things, especially like most of the application today are delivered as SaaS, and this is you need to control basically how people access these things. So it's more than SSO, is really control on all the information that goes in and goes out from the browser. So we actually need to add that thing here. That's why it's a difficult thing. But what happens if you do that? This is the surprise. So if you control the infrastructure here, this is perhaps, I think, the most insightful thing that happened to us when we started working on that, is that, well, you can see if things are trying to intrude inside your code. So you can see if there's an intruder. So what happened is that initially we were thinking of preventing data loss with this methodology here, but now we can do this for data intrusion. We can actually detect data intrusion in your code, and you would think this is like so it's actually a very novel way to think of that, because we actually even put a patent of all those things, and I explained to you how it works. But like one of the very useful stuff for development, especially for DevOps, and especially if you do DevSecOps, right, is that if things are going into your code that you don't want it to do your code, I mean, and it's you need to have a way basically to control these things. And one of the very known things are credentials, right? You don't want people copying credentials in your code, right? Because that's not a good idea, right? Then the credential ends up in GitHub and so on. So what you have to do, you have to buy a solution to scan your code, or to make sure that in your pipeline you have a way to detect credentials and all those things and so on. But again, you will do this only when the code is on the repo. But also not true actually. You can in VS Code, you can there's something that can detect if there's some kind of credential in the code, but it's most of the time is part of the CI/CD pipeline. You would prevent people, but still, nevertheless, a lot of hacking happen like that. People copy credentials in the code. This is one of the things, right? There will be personal data. There will be also malware and all things. They could be like, especially when you generate code or you copy code from Stack Overflow and you put it there. There could be malware, but also could be a license, right? What if like your developer goes on Stack Overflow, copies a big chunk of code, and there's an open source license and it's Apache license, right? So you might actually not able to technically it will actually make your code not compliant with the license term, and that's an issue, right? I can tell you when we got acquired by Snap, the first thing they did, they actually scanned the entire repo that we had for this kind of licenses and so on. So what's going to happen? So this is the surprise we had. So I'm going to show you something cool here. Is that, let's say now I'm going back to my environment, and let's say I'm going to do something very stupid. I'm going to cat my key. I have a key here for the especially the demo here, and let's get my SH key here. And I'm gonna put this, I'm gonna copy that stuff here. There you go. And what I can show you here is that what's gonna happen is I'm a security officer, I can see, there you go. It got detected. So actually the way we do this is that we're gonna monitor the clipboard and measure the entropy of the clipboard. You know, entropy is a measure of information. You know, remember this from college. So we actually measure if the content of the clipboard is actually extremely random, then entropy is high, and you can detect things. This is like in a nutshell. But you can also detect things. So you see, like here, this is like Miladin just cut that stuff here, and it got flagged because potential code and so on. But this is really, we put this in a SIEM, and we can actually I think so most of the time it's benign. This is paced, but it's slow security because yeah, it's not something that was really important and so on. But like for security, this is, I mean, what data intrusion detection is. You can actually detect everything's going to your code. We can also detect personal data. We can detect malware. We can detect all these things. So this is really game changer because like now you don't need to wait, you know, to be somewhere around your DevOps stages, later DevOps stages to have this thing, or you can have this information there. And this is only possible if you master the infrastructure, because you need to get basically all the ways people can put code in your thing. So this is the thing here. All right, continue learning. Having principle continuous learning, I think I wanted to address here. Simple continuous learning, foster cultural learning, and so on. You know about that. It's a bit more philosophical, but one of the things here is that you can see once you have visibility, once development are online, then DevOps take a different shape. You can have a bunch of information, you know. This is our Kubernetes cluster, scaling up and down every day, so we pay only for what we use. Again, this is running on AWS, so we have a region here. I think we have second region, but this is, you know, what it looks like here. And then also, you know, we can have like the amount of work that was done. We can have like, you know, what people spend on design development and so on. I mean, this is something we could actually think of every type of metrics that you want to think of, but it's just typically what can be done. So have a write-up for this if you want to, and if you, I'm sure this is not exhaustive, right? You can think of many other things, but I wanted to mention that this is the fact that putting about, you know, the fact that you put environments online gives you a lot of benefits that you can really think of how to implement DevOps practices, DevSecOps practices, and so on. So I think this is one of the things. So if you read the new stack, I think that published this a month and a half ago or something like that. Yeah, this is it. I wanted to show an extra application here on platform application, because I think this is something that is, I know platform engineers in the room, so I wanted to make sure that this is it's also interesting. You can, again, I'm not an expert in platform engineering, but I think that was an interesting stuff. Actually, I wrote an article on that as well recently. I could get accepted, I don't know which journal, but like I can give you the reference. So what happened is that because we have this environment online, I mentioned that the principle of a workspace is typically your environment online, but it's not only a container with software, right? Your workspace is actually more, so you can make it much more sophisticated. This is typically one of the workspaces. We have an abstraction of what is a secure developer laptop thing. We have developer experience in the workspace. You can configure which ID you want to use, or IDEs, plural. You can use more, or you can use Emacs, so you can use terminals and so on. Which basically secure browser use and so on. Also DevOps productivity, whether you use like dev containers, dev files, containers, and so on. We can also specify that. Asset utilization and cost governance. You can define where is your workspace running, which region, if there's a choice for that, or you can be optimized. What is the schedule is going to run, and so on. And here data control and access and so on. So data security policies, and all those things. So the goal is to break the monolith of seeing your environment just like a way you specify all the code and so on, but you can specify all the parameters. Like when the developer logs in, then she can have the entire environment completely customized for her. Typically the bash RC files, plugin for VS Code, and all those things, right? You completely ready, zero installation and so on. Typically these are the parameters that we'll have on that. So asset utilization, so on, this thing I was mentioning. For a developer, I want to have my M file, I want to have my GPG keys if you sign your commits, personal secrets, startup script, remote customization, connection to DevOps tools, ID customization, my SSH identity, you know, I can log in, it goes to the proxy this way and so on. So then this is typically the thing here. So how can we use that abstraction to onboard not only one person, but an entire team? So that was the idea for my platform engineering paper, is that why don't you say, okay, we can actually, you know, from a different tool, not the platform, like Jira, for instance, we can create a task that we completely onboard a new team and let the guys connecting, let the guys connect to the platform, but also the entire laptops, everything should be ready, right? So that's why I call this team as code. And this is the principle. So you have like the platform engineer here, we like, you know, use the API and use Jira to now, and Zapier, we actually use Zapier for this. I think you might be aware of Zapier, to completely create the thing. And one of the things is that you can create the entire team, but also what you can do, or you can create a project and so on, but you can do also a prediction. You can do predictive metrics, for instance, like you know, how long is it going to take for that project to be executed based on basically on the past data that you have. You can actually get this type of metrics, because from the data that was captured from before, you can do that. Or prescriptive metrics. What kind of machines should you use for that project based on the workloads that you had before? So that's what I call this team as code, and that's how it works. So we create a task, and the task basically we use the API and gonna create all the things. So I wanted to give you a demo, but it's always a bit weird to do it on, because it might actually not break, but let's see if it works. If it doesn't work, it's on me. So just ignore the language. There we are. I'm gonna create a task here, and I was like, my team, my remote team, for instance, right? If it is a remote team and so on. So I'm gonna put here project name, remote dev, because I want to create a remote team of a few people here. I'm gonna use the template for backend development security policy. That's gonna be a nearshore team. I'm gonna ask Bastien to join. There you go. And I'm gonna ask Bjorn to join as well. I shouldn't see, my eyes are so bad I cannot even. There you go. Is that strong.network? Yeah, that works. Success. I can build the stuff here. It's gonna start, and now open this task here. Show my partner coming up. Here, Osrenko is here. There you go. He created the project, and we should have the thing. Oh, there you go. New project created. There you go. So it takes about 20 seconds, and I need to display all the things. There you go. Things are deploying. So now Bastien and Bjorn can just connect to the platform and start working, and that's it. And you have completely configured laptop with everything and so on. Are we on time? No more time? All good? Okay. Anyway, I'm done. So that's it. There. Yeah. Okay. Okay. Oh, great. Any thoughts, tips on managing online workspaces that are very? Yeah, absolutely. So this is that's a very good question. This is what I mentioned before, is that the assignment of resources to the workspace is completely dynamic. You can actually specify this, just go in the workspace and edit the resources. Then you can use GPUs. So what's going to happen is that you have your Kubernetes pool of resources, and you can put GPUs inside. And what basically admin do, they do some templates in advance that people can use for their workspaces. But you know, we can actually, there's no limitation for this. But yes, GPUs are working very well. Actually, we have used GPUs also. We do some kind of we do data science as well. Any other question? Oh yeah, good question. You should take a break. Good, but fine, right? Yeah. No work. It's, you know, we're a connected world today, right? So yeah, you have to be on network. Like you're on the phone, you know, if you're depressed when you're on the plane because you can't connect, you feel like me. that's life. Yeah, but I know that's a very legitimate question. Yeah. Well, because I lived in Japan, I can't get out of it. So yeah. Oh, one background story. Yeah, just because I lived there, and this been my pet project for 15 years. Speaking Japanese. So that's it. And now you can do it with ChatGPT. I was mentioning that if you who's used ChatGPT 4.0. Okay, you can actually have a full discussion with it in Japanese. It's pretty amazing. I don't know if you tried that before, but it's unbelievable. So, yeah, that's it. Okay.
Yeah, no more questions. Thank you so much.